Okay, um, everyone, can you hear me? Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
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 The Honorable Rector of Universitas Jember, Dr. Insinyur Iwan Taruna, the Honorable Dean of Faculty of Engineering, Universitas Jember, Dr. Insinyur Triwahyu Hardianto, the Honorable Indonesian Education and Cultural Attaché in Malaysia, Muhammad Farid Ma'ruf, PhD, the Honorable Head of Civil Engineering Department, Faculty of Engineering, Universitas Jember, Dr. Insinyur Guspan Halik. The Honorable, our speaker from Department of Chemical and Process Engineering, Universiti Kebangsaan Malaysia, Professor Insinyur Dr. Siti Rozaimah Sheikh Abdullah. The Honorable, our moderator, Dr. Insinyur Yeni Dokika, and respected all participants. Good morning, everyone. First of all, I would like to introduce myself. My name is M. Fitra Bayu Adi. I'm from study program of environmental engineering, and I will be the master of ceremony in this guest lecture today. I wish to extend our warm welcome and thank you to all participants, guests of honor, foreign and local participants to this guest lecture, Potential of Waste Recovery and Reclamation in Agriculture Industry. Support by Faculty of Engineering and International Office of Universitas Jember. I'm optimistic that all participants will acquire new skill and knowledge from this guest lecture, and I will encourage all participants to take active part in the interesting discussion. Dear participants, before we come to the main session, the structure of our event today is follows. First, opening ceremony. Second, the speech from Indonesian Education and Cultural Attaché in Malaysia. Third, the speech from Rector of Universitas Jember. Fourth, praise session. Fifth, guest lecture main session. Sixth, question and answer session 1. Seventh, question and answer session 2. And finally, closing ceremony. For the opening ceremony, let's listen to the Indonesian national anthem, Indonesia Raya. For all participants, please open the camera. And for the committee, please play the national anthem of Indonesia. Okay, for the committee, please play the national anthem of Indonesia, Indonesia Raya. I'm sorry. Okay. Now, we hope all participants will enjoy and following this memorable video conferencing guest lecture event. Okay, Excellencies, ladies and gentlemen, to begin with, I would like to invite Indonesian Education and Cultural Attaché in Malaysia, Muhammad Farid Ma'ruf PhD, to deliver his welcoming speech. For Mr. Farid Ma'ruf PhD, please.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Selamat pagi dan salam sejahtera buat kita semua. The Honorable Bapak Rektor and the Honorable and our beloved Rektor Bapak Dr. Iwan Taruna, Distinguished Professor Prof. Siti Rozaimah, our colleagues in Engineering Faculty, Pak Triwahyu, Pak Krisna, Bu Yeni, and all, and also the students. I wish that you always in a very good condition in this pandemic COVID, and this pandemic contain us in the very restrictive physical interaction or activity, but I'm happy that still student and also this department still can do something like this guest lecture, yeah, or webinar online guest lecture. Prof. Siti, now I'm in Kuala Lumpur. I think we are close because
really?
UKM. Yes.
Oh, really? Oh, okay.
And I'm sorry that I never met you previously, but I went to UKM maybe about twice or three times because many students have exchange in UKM.
Oh, okay.
I have a good relation with international office.
Oh, okay.
Thanks for your sharing, for your time, and I believe that your very long experience in water treatment and your expertise will provide our students a great benefit, and also for our college and environmental engineering department. And we will learn much and more from you. And for your information, as education attached, actually a couple of months ago, we have new tasks from our higher education division, Kementerian Pendidikan dan Kebudayaan, that recently, actually, international cooperation has become key performance index.
Oh yeah.
For all universities in Indonesia. Yes, for all universities. Previously only encouragement. It's now a key performance index.
Okay.
That's why now all university higher education institution not only encourage but as a compulsory obligation for them to develop new and not only new, actually implemented international cooperation. International cooperation means only just signing an MOU, I think, because such kind of activities are very good for us. And I wish this there will be a start for you and for UPM, for UNED, for engineering faculty to maybe go beyond later for the cooperation. And also maybe for my colleagues in UNED, recently many students from Indonesia doing such kind of student exchange to Malaysia. Maybe only a couple of weeks, but also some of them doing credit transfer.
Yeah.
I wish that later you can develop such kind of maybe not only credit transfer, but also joint supervision. You join colloquium. We share facilities like maybe student from Indonesia can go to UTM, your laboratory, to do a final project or research. And also next couple years, maybe we can develop such like a joint degree or double degree or what. And I think So along my speech, and I will still for our student, for UNED student, this is a good chance for you to learn from one of the best experts in the world. So you have focus, and don't be afraid to just ask question to them. Okay. Enjoy this webinar, enjoy this guest lecture. Thanks. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you for the welcoming speech. For the second speech, I would like to invite Dr. Insinyur Triwahyu Hardianto, the Dean of Faculty of Engineering, Universitas Jember, to deliver his opening speech. Dr. Insinyur Triwahyu Hardianto, please.
Oke, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Bismillahirrahmanirrahim. The Honorable, the Rector of University of Jember, the Honorable, the Head of the Civil Engineering Study Program, Faculty of Engineering, the Honorable Educational and Cultural Attaché, Pak Farid. Long time cannot see Pak Farid. The Honorable Professor Dr. Insinyur Siti Rozaimah Sheikh Abdullah from Department of Chemical and Process Engineering, University of Kebangsaan Malaysia. Thank you very much for coming. Today is the second coming or Prof Siti to Jember. Welcome back to Jember, even though through virtual media. Last year in 2019, in November, Prof Siti as the keynote speaker at the International Conference of CCSE, the International Conference on Climate Change and Sustainability Engineering in ASEAN last year. And also the Honorable, my colleagues of the Civil Engineering Study Program, and also my students of the Civil Engineering Study Program, Faculty Engineering in Environmental Study Program, especially. Also webinar participants, lecturers, and students who may be from outside of the University of Jember. Alhamdulillah, this morning we can meet in a healthy condition to be able to study together, and we can attend a guest lecture that will be presented by Professor Dr. Siti Rozaimah. This activity aims to increase our insight on and also our knowledge related to the environmental engineering. This activity is also in a commemoration of the anniversary of University of Jember, which held on November 2020. Even though the COVID-19 pandemic situation is still not over, we can still work to improve our performance and increase our knowledge. After the pandemic is over, I hope we can meet and continue collaborative activities such as research, academic, and community services between our institutions. Finally, congratulations and participating in this webinar and representing the committee. I apologize if there are any shortcoming in this activity. Let me official open this event because of Pak Rector cannot come in this webinar because of has an official duty. Please let me to open this webinar with saying Bismillahirrahmanirrahim. This guest lecture is officially opened. Enjoy your guest lecture and thank you very much. And the time I return to the Master of Ceremony. Thank you very much.
Okay, thank you for the opening speech. Ladies and gentlemen, let's start this event with praying together, which will be guided by Arif Hidayatullah as committee. For Arif Hidayatullah, please.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Attention please. Before we start our event, let us say our prayers. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Allahumma salli ala Muhammad wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim innaka Hamidum Majid. In the name of Allah, most gracious and most merciful. All praise be unto the most gracious and the most merciful. Master of the judgment day, thee alone we worship, thee alone we ask for help. O Allah, show us the straight path, the path of whom you've blessed, not the path of whom you've cursed, and not the path of whom who goes astray. Rabbi srahli sadari wa yassirli amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidna ilma warzuqna fahma. Wa sallallahu ala sayyidina Muhammadin wa ala jamil anbiya'i wal mursalin walhamdulillahi rabbil alamin. Amin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, and before we start our main session, let's take a picture together. And for all participants, please turn on the camera for take a picture with our Dean. And for the committee, please.
Audience, please turn on your camera for the photo session. I repeat, please turn on your camera for the photo session. I'll begin in page 1. I will take picture on my count. 3, 2, 1. I will continue to the next page, page 2. Okay, 3, 2, 1. Page 3, on my count. 3, 2, 1. Okay. Page 4. On my count. 3, 2, 1. Page 5. On my count. 3, 2, 1.
Okay, thank you for the committee. And let's we start our main session, video conferencing guest lecture, potential of waste recovery and reclamation in agriculture industry will be delivered by our moderator, Dr. Insinyur Yeni Dokika, STMT. Dr. Insinyur Yeni Dokika earned her Master of Engineering degree and doctoral degree from Institute Teknologi 10 November, Surabaya. Her research specialization are grey-water treatment using wetland system and solid waste management. For our moderator, time is yours.
Okay, thank you, Bayu. Ladies and gentlemen, before we start the presentation, and in order to avoid any disturbances during the presentation later, I would like to ask you to turn on your web camera and mute your microphone. Thank you. The Honorable Rector of Universitas Jember, the Honorable Dean of Engineering Faculty, the Honorable Head of Civil Engineering Department, the Honorable Education and Cultural Attaché of Indonesia in Malaysia, the Honorable Speaker, distinguished guests, students, ladies and gentlemen. Good morning. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to welcome you all to this guest lecture about potential of waste recovery and reclamation in agricultural industry, held by study program of environmental engineering, Universitas Jember. In this occasion, we shall have outstanding presentation from our speaker, whom I believe shall enrich our insights and knowledge regarding the theme of this video conferencing guest lecture. Before the presentation begins, please allow me to introduce the speaker. Professor Insinyur Dr. Siti Rozaimah Sheikh Abdullah is a lecturer at Department of Chemical and Process, Universiti Kebangsaan Malaysia. She earned Master of Engineering degree from University of Nottingham and PhD from Universiti Kebangsaan Malaysia. Her research specializations are water and wastewater treatment system, phytoremediation, waste audit and management, and artificial intelligence pest control in wastewater treatment. She has been a highly productive researcher who has co-authored hundreds of research articles published in highly reputable scientific journals, including Bioresearch Technology, Energy, Journal of Cleaner Production, Journal of Environmental Chemical Engineering, and Journal of Water Process Engineering. The articles she co-authors have been cited more than 2,727 times. Her current Scopus H index is 25. She has been the project leader in consultations projects with companies in Malaysia, including Petronas and Malaysia Newprint Industry. For her excellent contribution in research and teaching, she has won numerous awards, including UKM Excellence Service Awards in 2017, STF Science and Technology Awards in 2015, shared with her colleagues in UKM by Malaysia Ture Science Foundation, 30,000 ringgit Malaysia, for outstanding achievements in the field of nanofiltration and ultrafiltration technologies for water and wastewater treatment. Good Medal Awards in Innovative Practices in Higher Education Expo in 2014 with her colleagues in UKM. Bronze Medal in 32nd International Exhibition of Invention of Geneva in 2004. UKM Excellent Service Awards in 2004, 2008, and 2011, and UKM Excellent Lecturer Awards in 2006, 2007, and 2011. Currently, Professor Insinyur Dr. Siti Rozaimah Sheikh Abdullah is a Deputy Dean, undergraduate in Faculty of Engineering and Built Environment, UKM, from 1st January 2020 until now. Without further ado, I would like to welcome our speaker to deliver a lecture entitled Potential of Waste Recovery and Reclamation in Agricultural Industry. Ladies and gentlemen, please welcome Professor Insinyur Dr. Siti Rozaimah Sheikh Abdullah. Time is yours. Thank you.
Okay. Thank you very much, Ibu Yani, for the kind introduction of myself. Okay. So, Assalamualaikum warahmatullahi wabarakatuh. To Prof. Dr. Riwahju, okay, the Dean, okay, to Mr. Farid, the Atasir representative in KL, okay, to Ibu Yani herself, okay, to all the lecturers, colleagues, okay, and also to all the students that joined the seminar, the lectures today. So, so the topic will be the potential of waste recovery and reclamation in agriculture industry. So I will try to share basically my knowledge and also share our, not basically I know everything, okay? So I will try to share whatever I have so far, and basically we can share among us, okay? Anything that we have gone through, so maybe we can share at the end of the presentation, so that we can learn from each other, okay, how to solve this waste or wastewater from agriculture industry. Okay, thank you so much to the Department of Environmental Engineering Study Program, Faculty of Engineering, for inviting me to give these lectures. I'm so honored, okay, to all, to Ibu Yani and also the colleagues, okay, from the department, okay, for always invite me, okay, since last year, okay, I basically physically be in University Jember in November 2019. Although now we cannot meet physically, but Alhamdulillah we can meet virtually, okay, through Zoom. So we can share and we can discuss, okay, about this topic. Okay, without any delay, let me share my slide. Okay. Can everybody see my slide?
Yes, we can.
Yes, we have.
Okay.
Can.
Okay. Thank you very much. Okay. So, so let me begin, okay, on my lectures on this potential of waste recovery and reclamation in agriculture industry. So I just want to congratulate to basically Universitas Jember, okay, for being 56 years, okay. And I would like to also inform that we, Universiti Kebangsaan Malaysia, also celebrate our 50 years old, okay, this year, okay. So our age is about almost the same. Jember is more senior than us, okay.
Yeah.
So congratulations to all of you.
Congratulations
Okay.
to UKM too,
Yeah,
Prof.
thank
Siti.
you. Okay, so basically, okay, so this is the topic, okay. Ibu Yani contact me about the topic, okay. on agriculture industry, basically how to treat this wastewater from agriculture industry. And Ibu Rani asked me to give a title for that. Okay, I just give this title, Potential of Waste Recovery and Reclamation, instead of wastewater treatment. Okay, why? Because nowadays, okay, in wastewater treatment, our main aim is not to treat, okay, but to try to recover anything that we can, okay, before we discharge to the environment. So that's why my topic, okay, I put recovery, okay, recovery and reclamation, okay. So this is the outline of presentation, okay. So I will talk about these introductions, okay, on the type of industry, basically on this agriculture industry, and what are the waste generated, okay, from this industry. So in order to treat, we have to know what's coming out from this industry, okay. And then of course, okay, once we know that, of course, okay, we try to see whether we can extract, or we can recover, or we can use, or we can convert something, okay, from useful things, okay, from the waste from agriculture industry into byproducts, okay, before we discharge to the environment, okay. And of course, in order to treat the waste or wastewater coming from the agriculture industry, we try to adopt the green technology, okay. Okay, so this is the what is agriculture industry, okay. So many things, okay, can be considered or can be categorized under agriculture industry, okay. So it consists of cultivating plants or crops, okay. So there are many, and I'm sure, okay, Indonesia is one of the country in the world, okay, that has a lot of industry, agriculture industries, okay, produce food, okay, for, of course, for Indonesian people and also for the world, okay. So there are many types of plants or crops, okay, especially in tropical countries, okay, like paddy, okay, palm oil, okay, tea or coffee, okay, anything, okay, that goes under cultivation, crops cultivations, okay. And beside that, we also have this cultivation or breeding of animals, okay, also for food, okay, like chicken, goats, okay, cows, okay, eggs, okay, fish, even fish, okay. So basically, okay. So, and the third one is on this on other type of agriculture, like, okay, like fiber or basically all these raw materials from 1 and 2, okay, we can process again, okay, to become other products, okay. So these are the basically the category that I managed to do to separate, okay, the primary industry and the industry, agriculture industry is basically to extract raw materials, okay. For examples, okay, on the crop cultivation, okay, we want to basically produce paddy, okay, palm oil and so on, okay. So on agriculture, also include the agriculture for fish farming, fish breeding, okay, and also for other types of animal, okay, cows, okay, goats, chicken, and so on. And of course, okay, all these, okay, the product from the primary industry, okay, will be passed to the secondary industry where we manufacture, okay, all these raw materials into other products, okay, and normally it's involved with food processing, okay. So like we can have, okay, the crude oil, okay, palm oil from the palm fruit bunch, okay, sugar from sugar cane, or maybe you can have the flour, sago flour, and others, okay, lots of things, okay, from that, okay. So and this is basically on the primary agriculture industry. Okay, so normally what we fed into the agriculture, okay, is about nutrients, okay, fertilizers, okay, pesticides, and also the water itself. Okay, so we need all this, okay, to fed into the primary agriculture industries. Okay, in order to plant, okay, crops, okay, to breed the chicken, the fish, and the lamb. And of course, at the end, okay, we'll get the products, okay, the useful products, okay. And don't forget, we also generate waste, okay. So this waste, okay, basically, so we cannot ignore this waste, okay, and we cannot say that we can produce zero waste, okay, it's impossible, okay. Besides the product, we also have this waste, okay, in terms of solid and affluent in liquid form, okay, and basically some traces of chemicals, okay, of the fertilizers or maybe pesticides, okay, inside the affluent, okay. So these are the primary industry. Okay, and if we think about this secondary industry or agriculture-based manufacturing industries, okay, mostly regarding in food industries, okay. So normally we use, okay, the raw materials, okay, from the crops, okay, from the animals and so on. And also we also need to feed into the water. We normally use a lot of water, and we have to supply the energy. Then in the manufacturing plants, of course, okay, there will be processing, a lot of processings, okay. And at the end, we got products as well, food products, okay, useful products for us, for our consumption, okay. For example, the oil, the coffee, the bread, the biscuits, or the sagu itself, or the beverage, okay, a lot of things, okay, that we benefit, okay, from this type of industries. And also, don't forget, we also have this waste, okay, waste, okay, in terms of, normally in terms of solids and liquids, the affluent itself, okay. And normally all these waste, okay, either from the primary or the secondary, normally the waste are rich with nutrients, okay. And we can classify the waste is non-toxic, okay, rather than toxic. It does not contain, okay, heavy metals or toxic chemicals, okay. But in some extent, they might also contain traces, okay, traces of maybe chemical fertilizers, okay, and so on, okay. Okay, so when we understand, okay, what goes into, what goes out from these agriculture industries, okay, so we have to understand all the waste coming out, okay, in order to treat, okay. But as I mentioned just now, our aim is not to treat, but try to recover first, okay, before we treat, or maybe along the treatment itself we can recover something, okay. So we can see, okay, on this agriculture waste, okay, so the main compounds, okay, constituents, okay, inside this agriculture waste, okay, is this in terms of solid. Of course, we can have these nutrient rich solids, okay, for example, the paddy husk, okay, sugar baggage, or even animal accretion, okay. And also there is some along traces of chemicals, okay. And also in terms of liquids, the affluent itself, okay, the affluent itself also, okay, contains soluble nutrients, okay, contains on this ammonia, nitrates, or phosphorus, okay. And also they might also contain nutrients rich suspended solid, okay, inside the wastewater itself. And apart from that, of course, there must be some traces of chemicals, okay, or even in terms of BOD and COD. So once we understand what coming out from the agriculture waste, okay, then of course we have to think, okay, what to recover and what to reclaim. Okay, either we can do it before we treat, okay, or along the side during the treatment itself. Okay, so I just want to show you. Okay, so basically all these ways, okay, of course, from the agriculture, we know that it contains mostly solid liquid, okay, that rich with nutrients, okay. But of course, other industries also emit or release all these waste, okay, to the environment, and at the end, everything goes to the environment, contribute to the environment, to the pollution and so on, if we don't treat or do something. Okay, and basically if we don't take any actions, okay, so finally we are the ones, okay, the humans, okay, on the earth that suffer, okay, due to the pollution. Okay, so one of the impacts, okay, so just now we know that agriculture waste contains a lot of nutrients, okay. So although we know that nutrients are not toxic, okay, not like heavy metals, they are not toxic, okay, but if we release it in excess amount, okay, to the environment, so we were going to face these nutrient pollutions, okay, and commonly known as eutrophication, okay, or sometimes they call as algae blooms, okay. This is the conditions, okay, when we release a lot of waste, okay, containing all these nutrients contain of these nitrates, okay, the ammonia or phosphorus, okay, without any restrictions, okay, to the environment, okay, especially in the aquatic life, okay, in the aquatic environment, okay. So that contents of nutrients, okay, will enhance, okay, the growth of algae, okay, sorry, they enhance the growth of algae, okay, inside the river or inside the ponds, okay. So this algae, okay, will bloom, okay, and of course, okay, after a certain time they will die. So the degradation, okay, of this, okay, requires the oxygen, okay. So that means, okay, the oxygen, dissolved oxygen inside the aquatic, okay, or in the water system, okay, will deplete, okay, soon, and will cause the fish to die, okay. And without we realize, okay, the eutrophication will occur, okay, naturally, and at the end, okay, we will basically having this problem, okay. At the end, we might lost all the rivers, okay. We cannot see any more rivers, we cannot see any lakes, okay. So this is the one threat that we will face in centuries, okay, not in months or years, but maybe in centuries, okay. Our new generation won't see lakes or rivers, okay, in future. So I've been in China, I think in 2008, okay, and attend a workshop, okay. So there is a lake in China, Taihu Lake, okay. This Taihu Lake, the size is about 3 times of Singapore, very big, okay. So it's like a sea for us, okay. So they have this algae bloom problem as well, okay, in the early 2000s, okay, where they don't restrict, okay, any discharge, okay, from the especially the agriculture, okay. So that it creates, okay, the algae bloom throughout the whole lake, okay. So this is a big problem from them, and they spend a lot of money, okay, to basically to mitigate all this algae bloom, because this lake has become a water resource, okay, for their human consumptions, okay. So we don't want to see this happen in our place, okay, the eutrophication or algae blooms, okay. So that's why our responsibility, okay, to avoid this thing happen, okay. So that's why we need to do something, okay, for our waste from the agriculture industries. Okay, so basically, okay, once we know the ways, okay, of course we know the impacts, okay, if you don't put any mitigations, okay, towards these pollutions, okay. Of course, okay, we need to go through carefully, okay, audit the waste, okay, whether the waste can be recovered, can be used, and so on, okay. And from this waste audit, we can know the quantity of the waste, okay, how much we can recover, how much we can discharge, and so on. And along that way also, okay, we can see, okay, whether we can convert into useful byproducts, okay. Try to minimize the waste, okay, discharge to the environment, and also the water itself, okay. So because in the agriculture industry, we use a lot of water, so we need to save our water. We need to try to make use of or reuse the water before we discharge to the environment. And of course, okay, at the end, some of the waste, although we have already gone through this recovery, reclamation, or treatment, at the end we still got some waste, okay. Then how to dispose it, okay, whether we can treat first or before dispose. Okay, so let me go on through this green supply management just to show you basically what is happening, okay, in our life, okay. So basically, sorry, just now, oh, okay. So basically in this supply chain management, okay, so we know that it start with this sourcing, okay, then going through the manufacturing and then distributions, and then of course coming to us, the human, the people, that consumers that use, okay, the product, okay. So basically all the ways, okay, we can know that we fed into water, we use the water, we use the energy, okay, we spend a lot of money, okay, to all this process, okay, before it can be reached to consumers. And along this process as well, so there'll be a lot of waste generated, okay. So basically, okay, so just now, okay, so all this process, okay, requires the water, the energy, the cost, okay, and of course at the same time there'll be some impacts, the outputs, okay, outputs into the environment, into the water, or into the sand, the land itself, okay. So everything, okay, everything goes to the environment, okay. So that's why, okay, in this supply chain management, okay, so we need to think of the environment. We need to think of the environment, not only when we have the waste, okay. We can think of this waste ahead, okay, at the concept and design stage, okay, before we start with all this process, okay. So it's good to think of the environment, okay, at the concept and design stage, okay, rather than only think when we have all the waste, okay. So basically, okay, so this is the stage, very critical, okay. So we need to think of, okay, the environment, okay, how to minimize the waste, okay, the back impacts, okay, the back inputs and also the outputs, okay, so that we can minimize the waste at the end, okay. So now we move to the waste minimizations, okay. So these waste minimizations, okay, so as I mentioned just now, is the best, okay, to think of the environment, to think of the waste, okay, before it's being created, okay. So that's why, okay, in the pollution prevention hierarchy, okay, so the strategy or the focus is to eliminate first the waste, okay. When we think of this waste, okay, at the design or concept stage, okay, we can think of how to eliminate first, okay, or how to replace. Maybe sometimes, okay, like in agriculture industries, we need to use this fertilizers. Okay, why not choosing for organic fertilizers, okay, rather than using the chemical ones. Okay, so that is the best way. Okay, because when we use the chemical fertilizers, at the end we will get chemical or toxic waste. Okay, so it's good to have to replace with organic fertilizers. Okay, and then think of reduce. Okay, reduce anything that we can reduce first. Okay, and then after that think of reuse. Okay, when once we have anyways, okay, we can think of the reuse. Okay, recycle. Okay, and also at the end finally we think of this treat and dispose. Okay, so the treat and dispose with will be the last options. Okay, but the first that we have to think is on the eliminate, reduce, reuse, and recycle. So think of this treat and dispose will be the last options. Okay, so that will be a good strategy. Okay, in protecting our environment. And we know that normally we always say that prevention is better than cure. Okay, so that's why eliminate is the best one. Okay, eliminate especially in producing toxic chemicals or toxic waste. Okay, so that's why, okay, when we think of this environment at the concept and design stage, so we can basically save a lot of money, although we cannot see maybe in terms of Indonesian rupiah or any currency. Okay, but in long term, okay, we can save our environment from the pollution, because once we have the pollution, then we have to spend a lot of money to bring back to the to save environment. Okay, so that's why it's good to have to think of these environments. Okay, think of this waste reduction opportunities. Okay, at the concept and design stage. Okay, so this is the concept. Okay, nowadays we try to adopt this zero waste concept. Okay, not zero waste, because we know zero waste is too ideal. Okay, in our life as well, everyday daily life, we also generate, okay, or excrete waste, okay, from our body. So that is a natural process. Okay, we cannot expect to have zero waste. It's too ideal. Okay, but basically, okay, we can adopt this zero waste discharge concept. Okay, so in especially in the secondary agriculture or food industries. Okay, when we have the manufacturing, okay, to produce, okay, from the raw materials. Okay, so to come up with the main product. Okay, so of course, okay, there will be waste generated. So once we think of this waste, okay, so try to think of the recycle, reuse, or reclamation. Okay, so basically, okay, so think of that. Then before we go for treatment, even when we go for treatment, so think also anything that we can produce or convert into secondary products or byproducts. Okay, and think of most of the time the water to be reused back to the process or even in the treatment itself. Okay, so so basically this is the concept. Okay, zero waste discharge concept. Okay, that we might think of, okay, in our manufacturing process. Okay, so this is the terms, okay, that we need to put inside our mind. Okay, to recover, to recycle, to reuse or reclaim or reduce. Okay, before the word treatment coming out from our mind. Okay, so okay, so and of course, okay, when we have the waste, okay, so we have to think on this pollution prevention hierarchy. Okay, and also, okay, when we have the treatment also, okay, so we need to think of that pollution prevention hierarchy, as well as to think of how to treat. Okay, how to treat is basically we try to adopt this green technology, uh, um, uh, uh, a treatment, okay, a treatment that will not harm the environment. Okay, so there are a lot of ways, okay, to treat waste. Okay, but nowadays, okay, people are trying to look for green technology. Okay, so what do you mean by green technology? Okay, so it's not only for treatment, but it caters, okay, any development or application of products and equipment and system. Okay, ultimately to conserve the natural environment and resources. Okay, and also to minimize and reduce the negative impact to the human activities. Humans, we are the humans on the earth. Okay, so we are the ones that benefit. Okay, if we go for this green technology. So some criteria, okay, of the green technology, of course, it will minimize the environment degradation, reduce the greenhouse gas emission, safe for use, and promotes healthy and improve environments for all type of life. Okay, not only us humans, but also all the lives, including the microbes, the organisms. Okay, the microorganisms, the bacteria, the algae, and so on. Okay, so we can live happily, okay, together in our environment. Okay, conserve the use of energy and natural resources, and also promotes the use of energy resources. Okay, of course, we can have a lot of benefit, okay, when we try to adopt this green technology. Okay, so just now I told you, if we once we have the waste, okay, so we need to think of this waste audit. Okay, so the aim of waste audit is basically to quantify, okay, so to see how much waste that we are going to produce. Okay, so this one also we can do it before we have the treatment. Okay, or along the way, the manufacturing process itself. Okay, so the aim is to basically to get the in terms of what will be the waste, and how much the waste will be. Okay, so the quality and also the quantity of the waste, that is the aim of the waste audit. Okay, so basically there are many ways to conduct this waste audit. Okay, so you can have as through visual assessment, or you can have through detailed audit through sampling or sorting, or you can also use process audit. Okay, based on basically on your process or the manufacturing process, what goes into what goes out. So it known as process audit. So we can get conduct or perform material balance in order to get this quantity of this waste. Okay, and of course, okay, we also have regulations. Okay, so we can think of comparing with the regulations. Okay, whether it's below or above, okay, the regulation. But of course, okay, we should think of this recovery or reclamation. Okay, before just to fulfill the regulation. Okay, so these are the stages of waste minimization that we can adopt. So just now I mentioned to you, we can adopt at the design stage. Okay, so at the design stage means that before we come up with this manufacturing or any agriculture activities. Okay, so we have to think, okay, we can guess, okay, what type of waste that we are going to generate. Okay, how are we going to deal with this waste. Okay, and maybe we can have a proper layout. Okay, not to basically mix, okay, the solid from the liquid waste. Okay, because we know that in the wastewater treatment process, at the end we will also produce, okay, generate the liquid or separate the liquid from the solid. So that's why in the early stage, okay, if we can plan plan correctly, okay, the solid try not to mix with the liquid, okay, or else it will be burden to the wastewater treatment process, okay. And of course along the manufacturing process itself, okay. So once you have already one factory, okay, that we are going to produce, okay, some products, food products, okay. So you have also to think on this, okay, the waste minimization on terms of source reduction, reuse, recycle, treatment and disposal, and also try to maintain all the processing units, okay, because once we don't maintain, then of course, okay, there will be inefficiency of your productions, okay. So that means, okay, more waste will be produced, okay. So that's why maintenance is very important as well, okay. So housekeeping just now on this, try not to mix, okay, the liquid with the solid, try to separate early, okay, and maybe treat differently, okay, in terms of energy and water as well, okay. Try to minimize, okay, to optimize the usage of energy and water, and basically, okay, so all these steps, okay, can be done, okay. Once you got this ways, okay, okay, maybe you can produce something, okay, from the biosolid, okay, convert into maybe fertilizers, okay, maybe for animal feed, okay, and so on, okay. So same thing on energy harvesting, okay, some of the solid, okay, or your liquid wastewater, okay, can be generated to produce methane or hydrogens, okay, promote for renewable energy. So all these things, okay, all these stages we need to think of, okay, along the way, when we produce, okay, or when we do any activities, okay, in agriculture industries, okay. So this is on the waste or wastewater treatment, okay. So just now I mentioned to you the waste, okay, coming out from the agriculture waste, okay, consist mostly solid and liquid, okay. So we need to think of, okay, whether it is toxic or non-toxic, but just now we know that from agriculture mostly non-toxic, okay, and it contains, okay, lots of nutrients that we can recover or we can do something with that, okay. We don't want just to throw it, okay, but we want to reuse it, okay. So same thing on the liquid, okay. Sometimes we might produce two different types of wastewater. Some is concentrated, some is dilute, okay. So we might think of maybe also separate this one, okay. So might be the dilute one, okay, uh, um, is already below the regulation limits, okay. So we just concentrate to treat the concentrated one, okay. So that's why in for the housekeeping it's good to separate this one as well, okay, or else it will be burden to the wastewater treatment, okay, after that. So the same thing, the solid also, we know it's non-toxic, it's biodegradable, and also it contains a lot of nutrients, okay. So this is the ones, okay. So basically what's inside the agriculture, okay. So mostly on the nutrients, okay, nutrients in the soluble form and also in the solid form, okay. So, okay, on the wastewater treatment and okay, so we need to think of this. What do you mean by wastewater? Okay, so now we think of this wastewater from the agriculture industries. Okay, how are we going to treat? Okay, so in wastewater treatment, there are three ways. Okay, to basically to treat. Okay, either you can do it physically, you can do it chemically, or biologically. Okay, and basically on the wastewater treatment, there are three stages: the primary, secondary, and the tertiary. Okay, so physical treatment, that means you need to use the forces, okay, the lot of equipment to separate the solid from the liquid. Chemical treatment, okay, you need to feed some chemicals, okay, to precipitate or coagulate. Okay, so that is using the chemicals. Okay, and the biological treatment is, of course, okay, you need you can use the natural resources, okay, like algae or plants, okay, or maybe bacteria, okay, to perform, okay, to help you to treat the wastewater. Okay, so all these, okay, of course, for each of the treatment there'll be uh, merits, or there will be advantages or disadvantages. Okay, so if you think of one way of treatment, of course, okay, sometimes, okay, it cannot meet, it cannot fulfill our purpose. Okay, so sometimes, okay, we need to combine all the three or maybe two. Okay, so it depends on the inputs, okay, what inside our wastewater and what is our aim at the end. Okay, so although we can see, okay, there are advantages or disadvantages of this physical, chemical, and the biological treatment, but you have to remember sometimes we need to use all of them. Okay, but as I mentioned just now, agriculture wastewater or waste, okay, normally is considered non-toxic. Okay, so normally we try to make use of the biological treatment, okay, or maybe physical. We try to avoid using the chemical treatment. Why? Because let's say, for example, we want to coagulate, okay, some suspended solid in agriculture wastewater. We use uh, coagulant like ferric chloride or alum. Okay, so those things are heavy metals. So although our wastewater is not toxic, but you mix with a toxic one, at the end you will come up with a toxic. So that waste will be categorized as toxic. Okay, so we try to avoid, okay, as we can, okay, as possible to use the chemical way, okay, for the agriculture industry. So these are the stages, okay, normally, okay, for basically for wastewater treatment, we have the primary,